Welcome to the lesson Cuboids and Cubes. At the end of this lesson, you will be able to define cuboids and cubes and derive the formula to calculate the surface area and volume of cuboids and cubes. Let's look at the objects seen in these pictures. Each of these objects have 6 faces that are rectangular in shape. Such objects are called cuboids. Now, if you look at the faces, the top and the bottom faces are parallel to each other. These are called the bases. The remaining 4 faces that join the 2 bases are called lateral faces. Cuboids have 8 vertices and 12 edges. The edges of this cuboid are its length, breadth, and height. Now, let's look at another figure. Here, the length, the breadth, and the height are all equal. Such a figure is called a cube. As you can see, the basic difference between a cuboid and a cube is the shape of their faces. A cuboid has rectangular faces, while a cube has square faces. These figures are also known as prisms. Let's look at a practical problem. You want to put up wallpaper in your room. To estimate the number of wallpaper rolls required, you'll need to know the area of the 4 walls. As you can see, the room is cuboid in shape. The 4 walls of the room represent the 4 lateral faces of the cuboid. If we add the area of the lateral faces, what we get is called the lateral surface area, or LSA, of a cuboid. Now, let's derive a formula to calculate the LSA of a cuboid. To calculate LSA, we have to find the areas of the 4 lateral faces. As each lateral face is a rectangle, we can apply the formula length into breadth to calculate the areas. We get the areas of each lateral faces as LH, BH, LH, and BH. Now calculating LSA is easy. All you need to do is add all these areas. On simplifying this expression, we get the formula as 2 times the height multiplied by the sum of the length and breadth. Let's rearrange this formula. Here the expression twice the sum of length and breadth is equal to the perimeter of the bases. Hence, we can also define the lateral surface as the product of perimeter of the base and height of the cuboid. Using the formula for LSA, we can derive the formula to calculate the LSA of a cube. In the case of a cube, all its edges are of the same length. Let's assume it is A. Substituting A in place of L, B, and H, we get the formula as 4A square. Consider a different situation where you have to paint an overhead water tank. In this case, you will need to find the total surface area, or the TSA, of the tank. Please note that the tank is cuboid in shape. The total surface area, or TSA, can be defined as the sum of the lateral surface area, or LSA, and the area of the 2 bases. Please note the areas of the bases are equal. That is, equal to twice the length into breadth. We have already derived the formula to calculate the lateral surface area. We'll now substitute these in the equation and simplify it. Please take note of the simplification steps displayed on the screen. We can use this formula to derive the formula for TSA of a cube. In case of a cube, the length, the breadth, and the height are equal. Let's assume these are A and substitute it in the formula. We get the formula for TSA of cube as 6A squared. Let's consider the water tank once again. How will you determine the quantity of water that can be stored in the tank? By quantity, we mean the volume or the capacity of the water tank. Let's first understand the meaning of the terms volume and capacity. The space occupied by an object is defined as its volume. Now, if the object is hollow, its inner space is empty. The empty space can be occupied by air or it can hold some liquid. The volume of substance that can be stored by the object is called its capacity. Both are measured in cubic units. Now, in case of the tank, if its length, breadth, and the height is known, then we can derive the formula to calculate the volume of the tank. Let's imagine the water tank is made up of H number of rectangular sheets. The space occupied by one sheet, or the volume of one sheet, is equal to the area of a single rectangular sheet. Similarly, the volume of H sheets will be H times the area of a single sheet. The height of the tank can be represented as H, and the area of one rectangular sheet represents the area of its base. Therefore, the volume of tank can be represented as length multiplied by breadth multiplied by height. As the tank is cuboid in shape, we can generalize this formula for the volume of a cuboid. In case of a cube, all its 6 faces are squares. Therefore, its length, breadth and height are all the same. Let's assume it is A. Substituting A in place of L, B and H in the formula, we get the volume of a cube as A cubed. Welcome to the lesson on surface area and volume of a cylinder. This lesson will explain how to calculate the area and volume of a cylinder. At the end of this lesson, you will be able to define a right circular cylinder and derive the formula to determine the surface area and volume of a right circular cylinder. A cylinder can be defined as a solid figure that is bound by a curved surface and 2 flat surfaces. The flat surfaces are made up of 2 congruent circles that are parallel to each other. These flat surfaces are called the bases of the cylinder. The radius of the circle is the radius of the cylinder. The perpendicular line that passes through the centers of the 2 circles is the height of the cylinder. Here are a few examples of cylinders. some of the cylinders are straight, while some are slant. As you can see, in case of straight cylinders, the height is at right angles to the base. Such cylinders are known as right circular cylinders. In this lesson, we will focus only on right circular cylinders. So when we refer to a cylinder, it means a right circular cylinder. Here's Padma. She has made a money box for her kid brother. She wants to buy colored paper to cover the box. How much sheet will be needed to cover the box? If she knows the total surface area of the cylinder, she'll be able to estimate the number of sheets needed. Let's derive the formula to calculate the total surface area, or TSA, of the cylinder. The TSA of a cylinder can be calculated by adding the curved surface area, or CSA, and the area of the flat surfaces. Let us first determine the CSA. If we unfold the curved surface of a cylinder, it opens up to become a rectangular sheet. The CSA of a cylinder is equal to the area of this sheet. Area of a rectangle can be calculated as length multiplied by breadth. In this case, the length of the rectangular sheet is equal to the circumference of the base of the cylinder, which is equal to 2 pi r. The breadth of the rectangular sheet is equal to the height of the cylinder. Substituting 2 pi r as the length and h as the breadth of the rectangular sheet, we get the area of the sheet as 2 pi rh. Thus, the CSA of a cylinder can be generalized as 2 pi rh. We derive the area of the CSA. Now, let's determine the area of the flat surfaces of the cylinder, which is nothing but the area of the base of the cylinder. The flat surfaces of a cylinder are made up of two congruent circles. Let's assume the radii of the circles as r. The area of each circle is equal to pi r squared. Area of two circles is equal to 2 pi r squared. As defined, the TSA is equal to the sum of the CSA and the total area of the flat surfaces. This is equal to 2 pi rh plus 2 pi r squared. This can be further simplified and written as 2 pi r multiplied by h plus r, where r is the radius of the cylinder and h is its height. We can generalize this formula to calculate the total surface area of a circular right cylinder. Before moving on, let's take a moment to solve a simple problem. Consider a cylinder can with a height of 25 cm and the radius of the base as 7 cm. You need to find the curved surface area and the total surface area of the can. As the height of the can and its radius are given, you can directly substitute these values in the formulae for CSA and TSA. Upon substituting and solving as shown on the screen, you get the area of the curved surface as 1100 square centimeters. Upon substituting and solving, you get the total surface area of the cylindrical can as 1408 square centimeters. Let's consider a cylindrical soft drink can whose height is h and radius is r. To find the capacity of the can, we need to find the volume of the can. By volume, we mean the space enclosed by the can. As the can is cylindrical in shape, we can calculate its volume by multiplying the area of its base with its height. The base area of the cylinder is the area of its circular base, which is equal to pi r squared. Therefore, the volume of the cylinder is equal to pi r squared h. Welcome to the lesson on cone. At the end of this lesson, you will be able to define a right circular cone, derive the formula to determine the surface area of a right circular cone, derive the formula of the volume of a right circular cone, and apply the formula of volume of a right circular cone. Look at this picture. It is the famous Pyramid of Egypt. The term pyramid seems to have become synonymous with this shape. But there are other shapes also that can be categorized as pyramids. For example, let's look at an ice cream cone kept upside down. It almost looks like a pyramid. Cones and pyramids look similar because they both have a single base and a lateral surface that joins at a common vertex. The difference is in the nature and shape of their surfaces. A pyramid has a flat and triangular lateral surface, while a cone has a curved surface. If you look at the bases, the pyramid's base is a square, and that of a cone is a circle. Please note that the bases of pyramids can be any polygonal shape. It can be a triangle, a rectangle, or a pentagon. Now coming back to the cone, it is solid with a circular base and a curved lateral surface that tapers in a point or vertex. Next, let's see how a cone is constructed. Let's take a right-angled triangle . If the triangle is quickly rotated along one of its sides, we can see a figure being formed. This is a right circular cone. The side along which the triangle is rotated becomes the height h of the cone. One of the two sides become the base radius r of the cone. A cone has a slant height L. It is actually the hypotenuse of the right triangle. As you can see, the difference between the height and slant height is that the height is perpendicular to the base of the cone while the slant height is not. Using the Pythagoras theorem, we get the relation between L, R, and h as shown. Please note, if h is perpendicular, then the cone is called a right circular cone. Okay, here's the situation. You have to make around 100 conical shaped caps for a party. How would you estimate the material required? If you know the area of one conical cap, you will be able to find the area of the rest. The total area of a cone comprises the curved surface area, called CSA, and the area of its circular base. This is called the total surface area, or TSA, of the cone. However, to find the area of the cap, you need to calculate only the CSA. Let's see how. Here's a sample of the conical cap. If we cut it along its slant height, it opens up to the shape as shown here. The straight edges represent the slant height L. The curved edge represents the edge of the circular base. Hence, the length of the curved base will be equal to the circumference of the circular base of the cone, which is equal to 2 pi r, where r is the radius of the base. Now, let's divide this piece into as many triangles as possible. The CSA of the cone will be equal to the total area or the sum of the areas of these triangles. The area of each triangle is calculated as half base into height, wherein the height is the same as the slant height L of the cone. Let the base of these triangles be B1, B2, B3, and so on. The total area of all the triangles can be calculated as shown here. Taking half and L as common, we get the total area of the triangles as half slant height into the sum of the bases. Here the sum of the bases can be substituted as 2 pi r. Thus the curved surface area of a cone is equal to pi rl, where r is the base radius of the cone and L is its slant height. Next, let's calculate the area of the base. The area of the circular base is calculated as pi r squared. Taking pi r as the common factor, the formula can be written as shown. Now, let's see how the volume of a cone is calculated. Consider a cylinder and 4 cones. The radius and the height of both the cylinder and the cone are the same. The cylinder is completely filled with liquid. Let's empty the liquid into the cones. The entire content of the cylinder can be emptied in 3 cones. This means that the volume of a cylinder is equal to 3 times the volume of the cone. Thus, the volume of a cone is 1/3 the volume of a cylinder.
Hey, welcome to our world.
We're all spheres. Our shape enables us to move effortlessly.
And land easy.
Is that why I'm kicked around? It's me, your good old pal Earth. Even I'm a sphere.
Welcome to the lesson on sphere and hemisphere. At the end of the lesson, you will be able to identify a sphere and hemisphere. You will also be able to calculate the surface area and volume of a sphere and hemisphere. So, what is a sphere? A sphere is a 3-dimensional figure made up of points that are equidistant from a given point. It is an object which is round in shape. It does not have an edge or a vertex. The surface of a sphere is uniform and smooth. Before we learn the mathematical properties of a sphere, let's understand a few fundamentals. The center of a sphere is a point which is equidistant from all the points on a sphere. The distance between the center and any point on the surface of the sphere is called the radius of a sphere. The radius is denoted by the letter r. A line passing through the center and joining 2 points on the opposite sides of a sphere is called the diameter of the sphere. The diameter is equal to twice the radius. It is denoted by the letter d. Now let's learn about the surface area of a sphere. The surface area of a sphere is the total exposed area of the sphere. Let's understand this further. Observe the sphere carefully. Let's draw a line on the sphere from one point to another on the opposite side. We will paint from one side of the line to the other side. Now, the whole painted area of the sphere represents the surface area. An example that will help to easily visualize the surface area is an orange. If you peel off the skin of an orange, the area of the skin represents the surface area of the orange. Is there a way in which we can calculate the surface area of the sphere mathematically? Yes, we can find it by using the surface area formula. If we have a sphere of radius r, we can calculate the surface area by using the formula A is equal to 4 pi r squared. You can observe that the surface area is equal to the sum of areas of 4 circles having radius r. Next, we learn about the volume of a sphere. What do we mean by the volume of a sphere? The space occupied by the sphere in space is the volume of the sphere. In order to understand the concept of volume better, let us perform an experiment involving 2 balls. See the 2 balls. Can you see that the volume of the red ball is exactly half of the volume of the blue ball? Let's try out an experiment. Here are 2 containers of same size, filled with water to the brim. Immerse the red ball completely in the container. As you can see, the water overflows. Let's collect the water and keep it aside. Then, immerse the blue ball completely in the other container. Collect the water. On comparing the quantity of water in the 2 measuring jars, we find that the quantity of water that is in the right jar is exactly half of the quantity that is in the left jar. So, we can say that the volume of the red ball is half the volume of the blue ball. Now, let's find a way to calculate the volume of a sphere mathematically. The mathematical formula to calculate the volume of a sphere is 4 by 3 pi r cubed. If you know the radius of a sphere, we can use this formula to calculate the volume. Then, we can calculate the volume of the balls or any sphere without performing an experiment every time. Okay, is there anything left to learn? Yes, we have to learn about the hemisphere. A hemisphere looks like this. How is a hemisphere obtained? Here is the procedure. Take a sphere and cut it into half. The sphere gets divided into 2 equal parts. Each part is called a hemisphere. A hemisphere has 2 faces, a flat surface which is called the base and a curved surface. Now, let's calculate the total surface area of the hemisphere. The total surface area of a hemisphere is the sum of the areas of the curved surface and of the flat surface. The surface area of the curved surface is exactly half of the surface area of the sphere, that is, 2 pi r squared. The flat surface resembles a circle, for which the area is equal to pi r squared. Therefore, the total surface area of a hemisphere is the sum of the areas of the curved surface and the flat surface, that is 3 pi r squared. You can observe that the surface area is equal to the sum of the areas of 3 circles of radius r. Now, let's calculate the volume of the hemisphere. Since the hemisphere is exactly half of the sphere, it follows directly that the volume is half the volume of the sphere, that is 2 by 3 pi r cubed.